Okay, what must be true about the slopes of two perpendicular lines, neither of which is vertical? And I'll talk about this idea that why they brought up neither of which is vertical in a second. I've talked about this before. Let's look at two slopes that are perpendicular to each other. Okay, let's say you have one that is -3/5 and the other one that is 5/3. Let's multiply them together. We get -8/8 or -1. Yep. Let's take another one. Let's say we have a slope of 2. Okay. The opposite reciprocal of that is -1/2. If you multiply those together, you get -2/2 or -1. As you can see, you always have uh, the product of the slopes is -1. Multiplying the slopes together gives you -1. Okay, so that's C. Now I just want to talk about real quickly why it says neither one is vertical, because a vertical line has a slope of undefined. So if you take the undefined slope, undefined, and of course a line perpendicular to a perfectly vertical line is a perfectly horizontal line, which has a slope of 0, multiplying undefined times 0, clearly that's not going to get you -1. Okay, so because these have weird special slopes, they're not really, they're still just two perpendicular lines, but this one has a slope that you don't have a number for it. Then this is 0, and of course anything times 0, if it was a number, would be equal to 0. Even though these two are perpendicular, they don't follow this rule. So that's why they had to mention neither one is vertical, because it doesn't work in this case. But otherwise, you get two numbers that are opposite reciprocals of each other, and when you multiply them together, you get -1. So the slopes of a product of -1. That's the idea.